Where is the option for the counter?
I think it was.
It was somewhere here.
Because I've seen loads of people using it.
Yeah. And
The
this is really
timer.
practical.
Yeah. Well, it was popping up automatically, and I don't know if it scrapes it somehow from the agenda. It was...
Okay, let's get started.
Yeah.
Hello, folks. It's time to start the session. So, welcome to the BESS session in Dublin. So, please read the note well. So, this is the last day of IETF. So, I'm pretty sure that you are used to it. But just in case you haven't read it yet, please do. So again, you should be used to that. So a couple of tips for the meeting. Don't forget, if you are on site, to join the queue using the Meeteco app. Also, please sign in so we can also have a big room next time. And for remote participants, please keep you on mute and just unmute yourself when you are allowed to speak by us. And Mancamana will take the notes, but if anyone wants to help and collaborate to the note, feel free to just provide more accurate view of what's happening during the meeting. So this is our agenda. It's quite packed. So I will ask all the presenters to stick to their slot. Unfortunately, as usual, we only have 3 working group documents for which we have update. So this is really a complaint that we have from a chair point of view, is that we always have bunches of individual drafts coming in, but we have very, very few updates on the existing work. So we really want the working group to really focus on closing the existing work, because the total number of working group documents that we have and that are not progressing is quite huge. So we'll really encourage the working group to really close the existing work. Thank you. So we have one new RFC since last time, which is this EVPN optimized inter-subnet multicast forwarding. And we have still a few documents in the RFC editor queue, especially the EVPN preference DF election, which is still waiting for the virtual Ethernet segment. And I think Gunther has also still a couple of things to do as well. So this is our current queue from an AD and ISG point of view. I really would like to thank Gunther because he already really helped to review a couple of drafts. So I think the ADQ is now moving in a better way. Many thanks, Gunther. Yeah, thank you, Gunther. But we have more for you, so if you are ready to take more. So, yeah, we have a couple of documents that are under our working group last call or Shepherd review. So for a couple of them, we are still waiting for IDR for a very long time, especially this EVPN unequal load balancing, which is defining some new community. So yeah, we are really expecting IDRs to provide some feedback. Sue, you wanted to say something?
I submitted that review during.
Your voice is really, really low.
It's very low. Hold on. Let's see if I can get it increased.
It's better now. Thank you.
Okay. I submitted that review during October, and the person responded. I can resubmit it, but they've already exchanged corrections with me, so perhaps you're out of date. I will posted again to the email. I also did BESS Geneve, which you have right, and I also did the multi-cast controller. So just so you know, Jeff has the review for BESS EVP and IVPN interworking.
Yes, and for this one, we really need the agreement because we think that normally everything has been addressed and this draft has been there for a long time. There is a lot of implementation, so we really need to close it.
Which one? The
IPVPN interworking.
That's in Jeff's hands.
No.
Because the authors and I came to a disconnect, and Jeff has agreed to pick it up. So I know he's online right now, so you can answer for himself.
Yeah, Jeff, if you're there, it'd be really appreciated if you could give us an update.
Yeah, so the status of that is I thought that it was over on your side of things. We had gone through and agreed on the contents. Is there another passive review that was required?
No, I think we were exactly waiting for that because I know you provided comments and the authors provided responses and updated the text. So I think it was just closing the loop on that updated text.
Okay, I thought that loop was closed. I will check my emails to see if I lost something.
Okay, thank you.
Jorge?
Yeah, I just wanted to say that I thought it was closed as well. So I think it's ready to move. Yeah.
Great, thank you.
Thank you.
And I on the Geneve draft, I'm chasing the editor to, he hasn't been responding to email recently. So I've been trying to chase the editor to address your comments. Thank you.
Okay, so we have a good number of documents that are almost ready for working group last call, especially the SRv6 argument. So this one we will do the working group last call, likely right after this IETF, and then we will move forward with the other one. Regarding the RFC 7432 BIS, there hasn't been so much discussion on the list on this document. So we would like to do a quick poll to see how many people have read the latest version of the draft, so we can see, I would say, if we can start to move forward with this one, because this is a work that we would like to close as chairs as soon as we can. So let me just open a poll. Yeah. No. The poll will be online, you know, for remote people. Okay, so the poll has started.
No, it's not automatic. But just give me a couple of minutes.
Okay, a few seconds left.
So just to clarify on the poll, I think, correct me if I'm wrong, yes means you've read it and you think it's ready. No means you've read it and you don't think it's ready. No opinion is you either don't care or you haven't read it.
Okay.
Where did the poll go? Oh, okay, you
No.
noted it.
No.
Yeah, okay, thanks. So it looks like a reasonable number of people have read it and think it's ready. There's one on this poll that doesn't think it's ready, but hopefully they've got some comments they can send to the list.
Yeah, and we can also address them during the working group last call.
But we'll confirm this on, obviously, with the working group article.
Okay. So we have also a lot of requests for working group adoption. As I said at the beginning, for now our focus will really be to try to close the existing work, because we have a lot of working group documents. So as chairs, we will really focus on pushing people to close the existing work. We will work on our side on doing the associated working group last call. And when we will see that the situation is moving in a better way and people are updating their working group document, we will start to proceed with additional working group adoptions. And one comment which has probably been made also at last IETF regarding the potential small changes or enhancement regarding the multicast VPN procedures. So we are still targeting to do a BESS version of the multicast VPN specification that will address a couple of the proposals that are coming from this individual draft. And I think we are expecting the first version of this BESS for the next IETF. Okay. So I think it's time for presentation. So the first presenter will be Patrice.
It's this one here.
This one.
Yeah. So now do it again. And then
Yeah.
Good morning, I'm Patrice from Cisco.
do you want to?
Yeah.
If you
There's
want
only
to.
one slide, so
Oh, okay.
because I have only 5 minutes, so I'll keep it short.
No.
All right. So this is about the EVPN VPWS seamless. I think it's the draft is quite ready. It's been around for 5 years. It's been very silent for a long time. I think there's no more comments that we've seen happening. I put here on this slide, like a bit what we are doing is just basically moving from target LDP or BGP AD pseudo wires to EVPN pseudo wires in a seamless way. So there's 4 steps usually that people will do, and we put also the concept of composite PE. The draft also talks very well about the multi-homing and all the load balancing, all the procedure. But as I said, it's been around for a long time, so that's why I'm asking for a work group adoption. Any questions?
Any comment? Yeah, Sasha was on the queue, but he's no more on the queue. So Sasha, you had a point or you're good? Yeah, you should probably be good.
All right, so please, work group adoption.
Sasha is back. Yeah, please, Sasha, go ahead.
He needs to unmute himself if he's.
You can talk, Sasha. We can't hear you.
Oh, it's gone. All right.
Okay.
All right, thank you.
Thank you, Patrice. Next presenter, Moncamana.
I can use the click.
Yeah.
Good morning, Mankamna Misra from Cisco Systems. So this is a quick update on weighted HRW. And just to give brief history, that it was initially presented in IETF 104, and we adopted, this got adopted by working group last year. The reason why we were silent for some time, because there were a lot of work going on during around this area, different algorithm for DF election. So we were waiting for them to get progress before we make progress in this draft. Just to recap the problem statement, as EVPN deployment is increasing more and more, we see more and more requirement with respect to load balancing the traffic. And load balancing not just limited to multi-home peer, but even from the remote side, if there are multiple endpoints which are having different capacity. And if you are provisioning new node in the EVPN network, how load balancing is going to happen. And we want to make sure that traffic is not really moving around when a new node is coming up. Just a recap to the proposed solution that it provides an extension to HRW to make sure that new provision doesn't really touch the existing traffic, or if even if it is some of the existing flows are being moved, they are very minimal. The next step for this draft, there were some review comment, not specific to this draft, but actually while having review of EVP and MHPA, that there is some more clarification needed with respect to HRW. So we'll work with Wen and Gunter to see that what kind of detail we want to add here and what is really needed. And after that, it will be ready for the next step.
Any question on this draft? No? Thank you, Kamana. Next one, Ali.
Thank you. At the rate we are going, I think we're going to be done in half an hour. So just a quick comment on the patch. I was going to go into the queue with respect to the draft that Patrice covered. We already have a sister draft for that, which is EVP and VPLS seamless interop. So the VPWS is just natural extension of it. So it is long overdue in terms of becoming and going through the LASCO. So with respect to this draft, I'm presenting it on behalf of the author. I presented it in the last IETF, and this is a pretty short presentation. I added one more slide on the signaling part and also realigned the text with what is in the draft. So let's go over the problem statement. What is the issue right now? When you do a IPsec encapsulation currently, you need to go read the entire, get the entire packet in order to find out what is the type and what is the length of the payload, okay? And when you do the cut-through mode, you basically operate at one chunk of the packet at a time. So you don't have the visibility into the last byte or the ESP trailer. So we need to have the information with respect to the length and the type at the beginning of the packet. So right after the shim header. So in order to accommodate that, we are proposing to have a shim header that is placed right after the ESP header that has the information which is in the ESP trailer. And that information is basically the packet type and the packet length, the payload length. And once you have that, then for the signaling part, in order to tell the other PEs that this is an encapsulation packet, we do it by signaling the tunnel type of the tunnel encapsulation TLV as cut-through mode. And then we have an extended community that we use for the NVO encap that indicates what is the NVO encap, whether it's VXLAN, NVGRE, and so forth. So we do that signaling in the BGP. And in the data plane, basically when the packet is encapsulated, the UDP part that of the other header, that indicates that this is a cut-through mode packet with the ESP plus shim header, and then Once you look at the shim after the ESP header, that shim, the packet type indicates what follows after that, whether it is a VXLAN, Geneve, whatever. We would like to solicit further input on this, and this is basically is very much needed when we're talking about the cut-through mode. It's a very simple concept, but it is very much needed.
Quick question as a working group chair. Which working group is managing the data plane part?
The data plane part, we are not making a modification to the data plane, but if any is going to be, I'm guessing the IPsec group, because
you are defining a new UDP port, right?
New UDP port, right? So, NVO,
because I don't think this is something that we can do here.
So we used to do it in NVO3.
Yeah, I know.
we do still exist in NVO3. I mean,
okay.
we haven't been meeting.
Okay.
If certainly we can meet again and we can do.
Maybe we can merge it with this one, you know, because there is a lot of common interest between the two.
Yeah, let's take that offline maybe. But.
Okay.
Any comment?
All right.
No, thank you, Ali. Next one, still you. Let me. Oh, Sue, go ahead.
I'm sorry, I'm a bit late. Ali, I'm going to send you a side note on the things you might improve in the description of the tunnel in CAP's work. I'm not, that's my only suggestion, is a little more of the standard format for that. Thank you.
That would be great. Thanks, Sue.
Okay, bye-bye.
Okay, let's move to the other draft.
Okay, this is the AD317 BESS E3. We did some update to the baseline RFC, which I covered previously. And in this version, we added a section for the SRv6 encapsulation, how we signal it for the E3. So a little bit of the history for this E3. We covered 3 scenarios. One scenario is when each PE for a given VPN instance, the leaf or root indication is on a per PE basis. So for that VPN instance, the PE is all leaf or all root. Then we have the next level of the granularity that we do the leaf root designation on a pair attachment circuit. And that is scenario number 2. And then we go to the next layer of the granularity that you do the leaf and root at the pair MAC layer, MAC address. So we have all these 3 scenarios, and it covers the draft covers extensively how we take care of each of them and so forth. And the only thing we added in this rev was one short section to discuss how we are taking care of the bump traffic for SRv6. For the so a little bit of the background for E3, if basically if the traffic is sourced from a root, it can go everywhere, including the leaf edges, but if the traffic is sourced from the leaf, it can go to the root devices, but it cannot go to the other leaf devices. So there are two cases in here. One is for the unicast and one for the multicast. In both cases, we need BGP signaling from the egress to tell, whether a given MAC address is associated with a root or leaf. And also, this is for the unicast and for the bump traffic to have a leaf label or leaf designation that can be used in the data plane. So that's the BGP signaling part. On the data plane, the unicast, for the non-unicast, you do ingress filtering and you don't need to do anything. Basically, it is very efficient. On the ingress, you know when a packet is come, whether the destination is associated with a leaf or root, and you can decide right on the ingress node what to do. For the bump traffic, you cannot do that. So you need to indicate when you send the bump traffic needs to have a indication whether that bump traffic got originated from a leaf or a root attachment circuit. We do that with MPLS by having a label associated with it if it is from a leaf. If it is from root, we don't do anything. And the idea in here for the SRv6 is basically same principle, okay? Designated with an indication, and that is argument FE2 in SRv6, which gets encapsulated in the seed part. So it is analogous to what we do for MPLS. Even the signaling is very analogous. It just like in MPLS, it gets sent in data plane as an MPLS label. In SRv6, it gets sent as an argument in the seed. And basically, this slide says in terms of the signaling, the egress does that signaling very similar to what we already do for MPLS by sending it to via Ether AD per ES route with ESI of 0. And then the ingress PE will use that arg FE2 in the data plane. Except this section which we added for the comprehensiveness to make sure that now we cover all the data planes, not just MPLS and VXLAN. The draft already covered MPLS and VXLAN. We just wanted to make it comprehensive and cover SRv6. And that little section cover SRv6. And all the existing ticks are in a pretty stable shape. And we are good to go in here. So I would like to request for a working group call on this.
Any question from the working group?
So for any adoption or last call requests, can you please also follow up by email?
Sure.
And in addition, we do have a wiki page tracking all the things we're tracking. If you don't see anything listed and you have requested something, please let us know.
Okay, sounds good.
Okay, let's move to the next presentation.
All right. So this is about the EVPN group policy, specifically for the VXLAN, with the VXLAN encapsulation. And a little bit of history, we presented that in IETF, 2 IETFs ago, and we covered the history that this new draft is a merge of the 2 existing drafts, and those 2 existing drafts have been around for a while, and they have existing implementation by multiple vendors, but it hasn't been able, we haven't been able to progress those drafts because of the issue that I'm going to talk right now. So before getting into the issues again, a little bit of the primer that the group, the VXLAN header is incorporated, the group policy ID is incorporated into the VXLAN header. As you can see in here, it is a 16-bit policy ID, and we are using a couple of bits in here, one G bit to indicate whether this group policy ID exists or not. And then the other one is A bit that indicates whether we have already applied this group policy on that node. If it is, if the node receives it and the applied bit is 1, it doesn't take any other action. If it is applied bit is 0, then it applies the policy and set the bit to 1. So, and then the control plane part of it is, well, we need to signal it, and we use an extended community to signal it. And in some cases, we can, that signaling is sufficient, and we can enforce the policy on the ingress. And in some other use cases, we cannot do the policy on the ingress. It needs to be on the egress. And when you do the policy on the egress, that's where you need to put the group policy ID in the VXLAN header. So that was, that's a primer. Now, what was the issue? The issue is this draft, the group policy ID draft, is based on the RFC 7348 VXLAN draft. And that we are talking about adding additional bits to the VXLAN header. Well, 2 issues. One is there is no IANA section in the 7348. So we don't know, because there is no IANA section, there is no precedence in defining the bits. And the second is 7348 was the individual submission stream and not the IETF document stream. And as such, that created the second issue. So to take care of this issue, we discussed it with our AD and chair. A special thanks to Gunther for giving us a big hand in this, and also Matthew in helping us to see how we can break this deadlock. And basically, as after discussion with the IETF trustee and all that, it was recommended that we need to re-spin the RFC 7348 and just add a IANA section, and then also make it a IETF document. So for that, I needed to get a hold of one, the original author, which wasn't easy because this is like a 15-year-old draft RFC. So I was able finally to get hold of him, and he agreed to the changes, and we added the section on the IANA, and we published that 7348 BIS. And also, now that the 7348 BIS has an INO section, we were able to easily extend that in our policy group, and we incorporated additional code points in our policy group. So both of these drafts right now, they're in pretty good shape. I would like to request for the 7348 to be expedited, and also for the other ones to place in a queue for a working group.
So just from an NVO3 chair's perspective, with that hat on, so what I think, because what I was thinking with this is because there's not a lot of visibility and activity in NVO3 at the moment, we should probably, Jeff, I can see you raring to go there, probably also kind of publicize what we're doing in the routing area working group to make sure that everybody is aware of this. I mean, basically the bits that Ali's talking about here are some reserve bits in the VXLAN header that are not, there was never a registry created anyway, and there was no intention originally, I think, to reassign them. So it's really that, and we need to obviously make sure that the due diligence is done on that change.
Justin Sura, NVIDIA's routing work group chair. So I think we had agreement about 5-6 ATFs ago that SFC and NVO leftovers, sorry for lack of a better word, will be finished in routing. So I would like to kindly offer the opportunity to do this so we can follow the formal process of doing this. So Ali, we agree with the chairs. Please republish the draft and routing, and we'll proceed there.
Okay.
Well, yeah, I mean, I don't know if we need to republish it in routing, but we need to make sure, because NVO3 still exists. It's not closed.
Yeah.
And
question, who is reading it?
Who's actually owning it, yeah.
Okay.
Adrian from Tottenham. I support the update of this draft, this RFC, because we also have the similar proposal that want to extend the VXLAN header to accommodate other scenarios. Okay.
Okay, thank you.
Yeah, Gunther van der Velde speaking here as a routing AD. So what we discussed with, what we discussed with the trust and what we have learned, is this thing working? What we have learned from the trust is that this, so this RFC, this 7348, is a technology not really owned by IETF, because it's an individual submission. And what they recommended is, like what you're saying here, is to make it like an informational kind of draft, but basically leave the content as is, and add the IANA section. And the reason is because if we start changing one little thing here, there is a big, massive risk for scope creep and all other sort of things, happening to the draft. Because think about it, this is an old thing, like 15 years ago. Many things changed in the IETF in many different ways. How document should be written. It is a non-trivial thing. So the overall understanding is to, republish it as is with the IANA section. And then if any changes then afterwards, because from that moment onwards, the document is owned by IETF, we can spin up a business onwards with more discussions. And I think then the question pops up, where should this work actually happen, in the future?
So just to sort of a little bit of history on 7348, it only changed, it was originally an informational document in NVO3. It only changed to the independent stream really at the last stage when it was in the ISG. And I think that was based on some comments that would have changed the design so that it wasn't necessarily completely aligned with the deployed VXLAN. And VXLAN is known to be very widely deployed. So the objective, I think, of the BIS draft here is not really to change anything really apart from being in order to create a registry for those reserve bits, but not to change anything else.
Jeff, go ahead.
Very brief comment. This is an opportunity to take this forward to full standard if people want to do that. It's at that level of maturity.
Yeah.
From reference perspective, wouldn't normative reference to informational draft create an issue for standard track draft? It's misref, right?
Yes. Yeah. I don't know. Did we discuss this? Maybe you could speak.
So I don't think actually that has been discussed. We'll look into it. Right now the idea was to bring this to informational, as is, because that is what it is. It's an informational kind of document. If you want to change the, if you want to bring it to standard track, for sure it has to be reviewed, and some things, will have to be updated and refreshed, based upon the current times. So I think that is, probably valuable to have, because many people run VXLAN, so it's probably worthwhile. It's a de facto standard, but it is probably a step more further in the future, I guess. From now on, I think that the low-hanging fruit is to make this thing informational so that the other work can actually progress and not blocked anymore.
Right. I think the issue is that the other work is a standards track draft, or intended to be standards track, and this is informational. So
like
making a normative, you can't make a normative reference from standards track to informational is the issue.
So that can happen. It's just like a down ref, not a misref, by the way. And that is possible, and we just put it into the down ref register, and those things are okay if that is accepted by the working group and by the IESG. So there is a process for that.
Okay. Any other comment on this draft?
No. Okay. Again, a special thanks to Matthew and Gunther, and not just for this, but also let me acknowledge in here, Gunther is doing a heck of the job in reviewing the drafts and giving tons of comments, and he's making us look bad, because the bottleneck is us, So thanks.
Next speaker is Jorge.
Thank you. Yeah, I also wanted to acknowledge Gunther. Great job. And thank you. Okay, so this is Jorge Rabadan, Nokia. This draft is about Anycast multi-homing in EVPN. This is the list of my co-authors. I'm going to talk about short refresh, then the changes that we made, and next steps. All right, so what is this about? In data centers, multi-tenant data centers, we use EVPN all over the place. And typically, we also use EVPN all-active multi-homing. And in all-active multi-homing, the way this works is we have this procedure called aliasing, which takes care of the case where, like in this example, when you have traffic from TS3 to TS1, leaf 3 can actually do per flow load balancing to leaf 1 and leaf 2, even if TS1 MAC was only learned on one of the two leaves in the first place. So that is what aliasing takes care of. This is all great, and along with that, EVPN all-active multi-homing comes with other advanced features. And it's all good and deployed and multiple implementations. But in data centers, especially in large data centers, some data center operators, they decide to not to use EVPN multi-homing, but stay with proprietary multi-chassis lag solutions. And the reason they give is, well, because, if they don't need the advanced features in EVPN multi-homing, multi-chassis lag is just as good, and you don't need the, the overhead of the signaling in EVPN. And the other thing is, they also claim that with multi-chassis lag, the forwarding in case of a failure in the underlay is actually more efficient. So because of that, the goal of this document is to have an extension in EVPN so that if you don't need the advanced features that EVPN multi-homing gives you, you can actually do exactly as what multi-chassis lag proprietary implementations do, but in a standard way and a bit better. The last point that I mentioned, the inefficient forwarding when you do EVPN multi-homing aliasing, is explained in this slide. And what I meant by that is, suppose you have Ethernet segment 1 as an all-active multi-homing, and traditional EVPN all-active multi-homing, and you have traffic from TS3 to TS1. Now, suppose, and because of that, so there is per flow load balancing, and leaf 3, sends traffic to leaf 1 and leaf 2 VTEPs. Suppose that you have a failure on the link between leaf 1 and spine 1. If that happens, the in-flight packets that are arriving at spine 1, basically they will have to be forwarded to leaf 2, spine 2, and back to leaf 1, which is not very efficient, especially because leaf 2 was already connected to TS1 in the first place. Now, if you use an Anycast VTEP in leaf 1 and leaf 2, which is what proprietary multi-chassis lag implementations do, in-flight packets arriving at spine 1, they can be forwarded directly to leaf 2 and TS1. So that is what I meant by this inefficient forwarding case. So because of that, we have this document that will make use of Anycast VTEPs for aliasing. What we've done in this revision 2 is we have simplified all the procedures. There was a lot of back and forth about how far we should go with this solution. So the agreement among the co-authors and that we wanted to share with you is that we wanted to have a simple solution as close as possible to proprietary multi-chassis lag solutions, only in a standard EVPN way. A single Anycast VTEP will be used for all the Ethernet segments attached to the same group of leaves. All the extra procedures that we had in revision 0 and 1, they have been moved to an annex. So people can still go there and read it for completeness, but the idea is to remove that annex when the document gets published. And we have also added an operational considerations section. So we had some feedback from Jeff and some others that this might be good to add. So we have this this section that warns about the operational considerations of using Anycast multi-homing as opposed to unicast multi-homing for aliasing, and also analyzes the use of Anycast VTEPs when you use eBGP in the underlay, as in RFC 7938. All right, so this solution in a nutshell is basically what you have here in the slide. So we are only changing the aliasing procedure. The rest of the multi-homing procedures are as they are. So DF election and the split horizon filtering and all that. So we split the procedures into egress MVE procedures and ingress MVE procedures. So basically the egress leaves, they advertise, they are configured for this Anycast multi-homing mode, right? And that is signaled in a special flag in the AD per ES routes. They're going to use an Anycast VTEP, and they need to advertise the reachability and the underlay for that Anycast VTEP. The AD per EV routes are completely suppressed. And in case of an ES link failure on, for instance, leaf 1, the AD per ES and the ES routes are withdrawn, as you would expect. And if leaf 1 still attracts traffic, unicast traffic for that Ethernet segment, basically we will fast reroute to leaf 2. At the ingress MVE, upon receiving the MAC IP route with an Ethernet segment, we program the MAC associated to the Ethernet segment, which is resolved to an Anycast VTEP now. Now the incoming frames are sent with an outer IP destination address of the Anycast VTEP, and that is per flow load balanced using the underlay ECMP set to that Anycast VTEP. As an optional improvement, basically if the ES destination can change to use the unicast VTEP, if only one egress leaf remains active for the Ethernet segment. So next steps, we want to get more feedback from the working group based on this modified document. We will work on some more content in the draft, specifically about the applicability to IP aliasing in SRv6. And after that, we will request for working group adoption. Any questions?
Janos?
Hi everyone, Janos Farkas, affiliated with Ericsson. Purely just for your information, multi-chassis is part of the link aggregation standard for 10 years now, 802.1ax. And if you want to check, I suggest to check the latest revision, .1ax 2020. It is called Distributed Resilient Network Interconnect, not multi-chassis Slack for the legacy. I'm sure the deployments refer to really use proprietary multi-chassis Slack, but you use proprietary so many times, there is a standard for it.
So you mean we should refer to that as well in the document?
I leave it to you.
Okay.
It's for information. It's not just proprietary. There is a standard for it for 10 years.
Can you talk at the mic if it's a...
If I may, but I think the...
State your name.
Ali suggested Cisco. The implementations that we know of, with all the vendors who are the co-author of this draft, those implementations are proprietary. They're not based on the standard.
Agreed.
I agree that the standard exists, but with respect to deployment, current deployment, they're all proprietary.
Imanshu is the next one in the queue. Jeff, you need to use the app. Yeah. You can be the next one. That's fine.
Himanshu Shah from Siena. I have a question. So in your previous diagram, so if tenant system 3 is doing ECMP to the tenant system 1 and 2 based on the flow identification and all that, now that you are sending it to the Anycast, and the underlay is doing the ECMP, is that a conflict? Because underlay is doing ECMP. Well, let's say for TS3 was wanting to send the flow to TS1, but the spine would not know whether the traffic should be going to TS1 or TS2. So you have a conflict there.
I'm confused when you say TS because the ECMP is
from
handled by the leaf.
The leaf one, yeah.
Okay.
The leaf one. TS1 is the end system, but yeah, TS1, the leaf 1 and leaf 2.
Yeah, so
leaf 3 is doing the ECMP. He wants to send it to the leaf 1.
Yes.
Based on the flow identification. But now, because of the Anycast VTAP and the spine is doing this, the ECMP, shouldn't, what if he sends it to the leaf 2? But the intent was to the leaf 1. So if I may, can I jump? Yeah.
Yes, you can. Yeah.
I'm just going to jump quickly. We are replacing the overlay ECMP with the underlay ECMP. It still is going to be ECMP, still we're going to get impact, same effect, but it's not going to be identical. Overlay ECMP and underlay ECMP, they're not identical.
So TS3 will not be doing ECMP. It is like all active multi.
Leaf 3 will be doing, in this case, a typical spine leaf architecture. Leaf 3 will do underlay ECMP based on the destination Anycast VTAP. It'll send to spine 1 and 2 based on a per flow basis, right? And then it's up to the spines whether they send a particular flow to leaf 1 or leaf 2, because both are advertising the Anycast VTAP.
No, I'm specifically talking about the EVPN all active leaf 3 doing the ECMP on the overlay. And how does that conflict with?
That is removed, really.
So basically, his question is, before we were doing ECMP on the overlay, so the overlay, the remote PE decides where to send it to. Okay, like a PE1 or PE2. Okay, and the remote PE was deciding, and because it was done in overlay. What I'm trying to say is because we are doing the ECMP in the underlay, right now the underlay takes care of it. Okay. Overlay doesn't
No,
have to
you
worry.
just have a single BGP path, so there is no multipath anymore at the BGP level.
Yeah, that's correct.
Justin, so to reiterate, there is only one known standard in IETF for multi-chassis synchronization, which is ICCP. There's nothing else. I mean, the VPN does the same, but it's not formally a standard for multi-chassis synchronization. So it doesn't exist from IETF perspective. I would like to reiterate my support for this work. Please extend Section 5, IP addressing, and operational considerations, especially if you're in data center. Usually you don't upgrade entire fabric, you upgrade the pod. So you definitely need to address Himanshu's point, what happens if you have old P, new P, and how they interact.
The NICA's use is really on a per Ethernet segment,
which might span multiple pods.
Yeah, that's correct.
So the operational consideration section need to be extended to address this.
Okay, that's what you meant. Okay.
Yeah. So please do continue.
Yeah. We'll probably contact you for to make sure that we address your concern. Yeah.
Patrice, you had a question?
Patrice Cisco. No, it's more comment. Thanks for the work. It's a really good work. Just one more comment on this is in terms of convergence. This draft allow us for very fast convergence whenever there's a node failure. So if you can state it somewhere in the document, it's really good.
Sure. I mean, it talks about the FRR. It talks about the makes it more efficient from the underlay perspective. But sure, if you have comments, we can add them.
Any last comment on this draft? Or are we good? Okay. Thank you. Next presenter, I think it's Patrice. You are presenting in behalf of Luc André.
All right, Patrice Cisco. All right, this morning I'm here to present, to present the EVPN fast reroute on behalf of the co-author. All right, so the EVPN fast reroute is something that we've been working for a very long time already. We address the convergence whenever there's like a failure in the access, especially with the multi-homing, highly applicable to the previous presentation as well. And what the draft is really covering is two major behavior, right? The first one is whenever you have the failure in the access and you have non-DF addiction on one side of the leg, what we are doing is we are defining a way to bypass the DF addiction in the forwarding plane. So therefore you can go pretty fast on the redirection. And the second thing that we are doing as well is we are preventing a ping pong loop between the two PE, right? So if you have two PE multi-home, you redirect, and the other guys is also failing, you don't want to have a ping pong back into your face. So the whole mechanism and procedure allow to prevent any of these type of feedback. What we've done also is we cover pretty much all the underlay, right? The MPLS, VXLAN, and SRv6. So we also incorporated a lot of feedback from ADS. All right. On this one here is the draft is also working very well with, well, as I mentioned, the previous one for the unicast aliasing, but it also covered well with AC-aware bundling and the L3VPN all-active multi-homing, which is still a private draft, but we asked for workgroup adoption a couple of times on that one. So the status of the draft is very mature. Again, it's been deployed like by multiple vendor. A lot of customer has it also, by the way. There's also like another draft which is presenting the SYN for SRv6. So we have discussed with the other
authored that draft, and I think the agreement was to merge the two drafts together into this one. So for the future, then we'll have just a single fast reroute draft, just for you guys to know. Yeah, and I think I know there's a lot of interest. The mailer, we addressed everything that was there. So this draft is definitely ready for workgroup adoption and is quite overdue.
Himanshu?
Himanshu Shah from Sena. I sent some comments on the working group list about handling of the broadcast packet.
Okay.
I think there is a way to do that, and I would appreciate if you put that language in there.
Perfect. I'll have a look. Thanks.
Okay, thanks.
Jorge?
Yeah, Jorge Ravadan, Nokia. Just yeah, we discussed with Himanshu, and but with his suggestion to redirect the bump traffic, it might not be easy, straightforward, and even for VXLAN, if you use global VNIs, it might be impossible. So we'll see.
I cannot comment myself. I haven't read the comments. So.
Yao?
Yao from ZT. And now this draft for the SRv6 part, there's only defined for DT2 and DX2. So is there any considerations or plans for the L3 EVPN part for SRv6?
I think, first of all, we're going to work or complete the merging first. The L3 multi-homing draft is covering also a part of it. So we will make sure that it's very clear how this has been covered. Thanks for the comments.
Okay.
As a working group chair, just one comment. I think there was already some work regarding a Reaper label for MPLS that could cover a part of L3.
Okay.
Do you remember that, Ketan, maybe? If it was in IDEA, this was a draft from Satya,
yes,
if I'm not mistaken.
Secondary label.
Yeah.
But I think the question was about SRv6 part.
Right.
And this draft is EVPN focused, and it does all three data planes for EVPN. So I don't think.
No, but the question is, if we have to do something for L3,
it could be a separate draft.
Yeah, absolutely. But we need to see there is already some ongoing work for the MPLS part. If we need to try to combine, let's see.
Yeah,
okay? But I agree. This one, let's keep the focus on EVPN.
And also, we need to make sure the L3 is well defined, because you can have an Ethernet connection as an L2 into an L3 interface, or you can just be an L3 service. So we need to make sure it's well defined.
Sasha?
Do you hear me?
Yes, there is a lot of background noise, but we can hear you.
Yes, I apologize for the background noise. I just want to reiterate my support for the draft. I have at Vancouver, I have asked to speed up its adoption as a workgroup document. That's all.
Thank you, Sasha. Any other last comment before we move forward? No.
Thank you.
Thank you, Patrice. Next one.
This is Chang Wanling from New H3C. This draft is about a new feature FR for SRv6 services. This draft describes the use case of no FR services and define a new flag for it. The update history of this draft, we presented at 2 IETF meetings and revised the draft. We changed the bypass seed to no FR seed, and we split our draft in two different two separate draft. This draft focused on non-feature FR. Yeah, okay.
Close to the mic. Close to the mic.
Yeah, okay.
Just stand back a bit.
Yeah. This draft focused on no feature faster rerouter. We also added L2 VPN scenarios, and our solution applied both the L3 VPN and L2 VPN. And we added a consideration for European single active mode. This is the use case for our draft when we deploy the fast rerouter on egress P node. When the link between P3 and C3, P4 and C3 failure at the same time, the routing loops can occur between P3 and P4. So the solution is very simple. We used another no FR service seed. Each P egress node advertise the no FR service seed, and no FR service seed has no local FR repair protection. So each P egress node can use each other's no FR service seed as backup seed. For European single active mode, the no FR service seed does not check the DF state. For the BGP extension, we just defined a new flag in SRv6 service flag. We define the N flag to indicate the no FR SRv6 service seed. It has full backup capability with current RC 19252. In our draft, we just used the flag rather than define the new SRv6 behavior. For the reasons, the first reasons because the segment routing architectures and the IGP access does define the backup flag for SRv6 seed, and using their various behaviors that using SIG flag is more simple than defining a new for existing behavior. We can compare our draft to European fast rerouter draft. European fast rerouter draft need to define a new behavior and just focused on European L2 VPN scenarios. Our draft applies to both L3 and L2 VPNs and just use the simple flag to define the no FR SRv6 flag.
Yeah. Okay. Can you just conclude because we will be out of time and there are 3 people in the queue, if you can.
Yeah. We can also use just one service seed with arg-link or arg0 or non-arg0, and we just assign one function to one for local FR, one has no local FR repair. We had more discussion with European fast routers authors, and we could have collaborations offline. Thanks.
Ketan, you're the first one in the queue. Try to keep it short if you can.
Just one question. We did have discussions between the authors. Luke is not here, so I was helping out. I believe we have agreement to merge or cooperate on the EVPN document. Is that correct?
Yes.
Okay, thank you.
Yes, thanks.
Jorge?
Yeah, Jorge Rabadan, Nokia. So what you are saying here about the using an argument, that's not in the current version of the draft, is it? I'm confused because I went through the draft and talk? And
This does not in the latest draft. Yeah.
Yeah. So this came after we had a discussion yesterday. So we are converging on the same solution, I believe.
Yes.
Okay, thank you.
Yes,
And
thank you.
just one more thing, because the draft in the current shape, I mean, you're saying that applies also to L2 VPN, but it should refer to the FRR draft, because for EVPN you're missing a lot of procedures. So
yeah, if it's merged anyway,
all right,
this one will probably die.
Yeah, thanks.
Yeah, thanks.
Thank you. Next presenter is Radko. Let me share the slides.
Good.
Yeah.
Okay, good. Thanks. So my name is Ratko Kvachina, and I will be presenting just a quick update on behalf of all my co-authors. This is originally presented at IETF 118 in Prague, and this now will just do a quick refresh and summary of the updates, and based on the comments and suggestions received so far, and propose some next steps. Yeah, you can go on the next slide, please. Yeah, thanks. The main goal of the draft is really to describe and present the interactions and integrations between the two technologies, SAVI and EVPN. SAVI being mature technology that's already have it's a set of drafts in a working group. It's technology that's intended really for large networks. It scales based on its proposal to have a database. Its database of IP addresses distributed across all access switches. The technology is focusing on address validation at the layer 2, the LAN layer. And at the key centers is the technology is to rely on a DHCP assignment to provide authority for the source address, and the other one is on a first come first serve basis. Basically, once the IP address is detected in the network, the first one is authorized. If it shows up next somewhere else in the network, then it is treated as a duplication or a theft. Next slide, please. So why did we write a draft? First, it's interaction between EVPN and the SAVI. I think there is a good case to bring to describe how the SAVI level of protection can be brought into the internet EVPN. But also with the security and the protection, there is some price to be paid in terms of performance, or in terms of the overall traffic in the network, which is highlighted here will be broadcast, like as a SAVI and first come first serve. Validation really relies on validation of across the network, and it's the link layer multicast or broadcast will generate the traffic, and broadcasts and multicast is not necessarily friendly. In this context, there is a delay to be anticipated, because it's in order to validate the presence of the hosts, whether it's during specifically during a move, host move on that performance could be impactful, and also for for hosts that have a DHCP assigned address, there is a different price to be paid there in that context, that the host needs to be validated doing the lease query and so on. So that's why we, starting from the interaction, we moved also brought up to the point to integration, so that some of these costs or price to be paid could be addressed and kind of minimized or eliminated. And this draft that we wrote here is addressing point 1 and 2, and there is another draft that addressing point 3 here.
Radko, you just have 30 seconds left to close your presentation, and you have 4 additional slides.
Yeah. Okay. So can we move on to the next slide, please? Yeah, this is a summary updates of after the updates addressing comments from the last from the initial presentation. One important part is to clarify integration part when IP address is not found in the EVPN table, and to address the BGP propagation delay consideration. So this was upgraded in the document to take this into the account, BGP propagation delay. And the next one is also marked that with this SAVI is implemented, the point that was duplicate up IP specified in RFC 9161 will actually never kick in. Added section about interaction with the subnet and how does it fit with the subnet, and some naming convention updates throughout the document. So those were the updates based on the comments that we received so far on the draft.
Yeah, can you just conclude, please, because we will be.
That's like if you move to the next slide. Yeah, it's like the next step is to request more feedbacks and the comments on the work, and the next step is, since this is becoming really stable, to kind of consider ask for a work group document adoption.
Okay, thank you. We'll move quickly to the next one. Thank you, Radko.
Thank you.
When?
Hi, I'm Wen from Juniper Networks, presenting here on behalf of all the co-authors. So this draft has been presented in IETF 104. So today, just to refresh and give more explanation why this is needed, what the area this draft address. So this draft address MAC IP binding when a gap when there's a system suffered node failure or link failure. In the EVPN multi-home case, MAC IP binding can be learned by EVPN-PE, but data plane learning may be only realized through one of the P due to the lag hashing, the ESI lag hashing. So in that case, if the network suffer node failure, in this case PE1, or access link failure, the MAC plus IP information is gone from all the network. So what happened is when access link or node failure, the MAC IP information is gone, and traffic, if coming from CE, will still need to send to the remote site, remote CEs. It can cause flooding, and so just basically we're trying to address this before MAC IP relearned how to avoid this excessive flooding, and also potentially they could be traffic backhauling, because non-unicast traffic is now treated as unknown, so it's going to flood it. Flooding require DF, non-DF, the status, depending on the DF, non-DF status. So if the ES link failure, is the P happens to the DF, so the new DF has to be elected. So if it's not done on time, forwarding is not programmed on time, the traffic could be backward. So there are a couple solutions to address these issues just during the gap. It can be done. One of them I talk about here is can be done globally. This require all the PEs to coordinate. So all the PE can have a hold timer, not remove the MAC plus IP binding for a short period of time until the MAC IP is relearned. But this process require both data plan learning and more importantly, also relying on the control plan, because relearn the MAC plus IP has to be re-advertised to all the rest of PE on times. If it's not done on time, depending on the network scale and the performance, so you could still have flooding. Or we can look another way is you deal with locally. Can we just deal with by each peer home PEs and make the remote P out of that solution so they can be transparent system until system recovered. So just want to trying to make it clear there is other things like when the node fail or egress link fail, there is other things going on. Traffic can be fast rerouted for in-flight traffic. So as also in this BESS group meeting today, there is as a proposal has been presented for FR, but this draft is not dealing with how to do FR for in-flight traffic or for a node protection for fast reroute for EVPN. But right now we do not have a node protection mechanism. But so this draft is not about in-flight, how to talk about FR for that. So the solution is this draft what describe is trying to address the problem locally through their peer EVPNPs. So in order to make it transparent to remote Ps, in the steady state, all the Ps, even though they have not learned the MAC plus IP binding locally, but once they received type 5 from their peer multi-home PE, they will also advertise the MAC plus IP in EVPN type 2 routes in the control plane to distinguishing this is data plane learned MAC versus this control plane learned MAC. They will have a proxy bit set in the UpND EVPN extended community. This proxy bit will be ignored by the remote P. So the remote P will just behave as it is. Remote P will just behave if they do not need upgrade or to know. So in case the PE suffers a failure or to the remote PE, they still see the type 2 MAC. They did not know there is a proxy bit set because they haven't been upgraded. They ignored this bit. Okay, so for them, the MAC plus IP is still there. So you do not need to coordinate for all the rest of the PE. What it does is the peer multi-home PE quickly, they see the real MAC plus IP got withdrawn because from P1, that advertisement without a proxy bit. Because of that, they see no other PE have advertised this type 2 MAC plus IP routes without a proxy bit. They know some action needs to be taken care. So they will quickly trigger the up and they set an age time as long as the up response getting back relearned within the agent time. So they will, one of them relearned. So that P will advertise update its existing type MAC advertisement without proxy bit. So this way, things will be done more seamlessly to the remote PE. They do not need to be aware because the learning has been restored within the aging timer. This is all this draft is about. And I want to summarize here what this, it's just closing the gap between the link node failure and the subsequent of relearning of MAC plus IP and avoid race condition or avoid unnecessary flooding in the network. And also want to mention, because the MAC plus IP has now is in the multi-home scenario is advertised by all the P, not just the P learned MAC plus IP locally. In essence, it also actually solving the IP aliasing feature, just bring you the IP aliasing feature in a different way, but it's through all the P's actually multi-home P advertised MAC plus IP. And the other advantage of that, there's no upgrade is needed for the remote P. Only P and multi-home P need to be aware of whether the advertisement has a proxy bit set or not set. So I do want to point it out because now all the EVPNP will advertise type 2 routes. So there is increased advertisement and processing in the control plane for the type 2 routes. So just need to point this out if control plane scale is concerned for your router, so you need to consider that. But it does not increase the footprint in the forwarding plane. Okay, the current status, we know this has been implemented by multiple vendors for many years, for a couple of years, and also the open source FR. So at this point, I'd like to further seek comments, and also I think we think this needs to be a work group, BESS work group document, since all the implementation up in the field, and we haven't actually really heard any complaint about the scheme has been used in the field. Yeah, thank you.
Sasha, very briefly, if you can.
I have sent my comments about this draft several times to the authors and to the work group, and the last time I did it early this morning because I wasn't sure I would be able to connect to this meeting. I think, in a brief summary, I think that the draft is a good candidate for the work group adoption because it addresses a highly relevant problem and looks like a good starting point for a solution. I think that the draft could benefit from clearly exposing the use cases. Just effect is that there are no network diagrams with the relevant use cases in the draft, which from my point of view are very helpful for the readers. I think there are several issues that should be editorial points that should be addressed. But again, I think that the draft is a good candidate for the work adoption.
Thank you. Ajun, very, very, very briefly, because we are out of time for this slot.
Okay, so I want to ask, what's the reason not all of the multi-home PE get the same MAC IP binding table? I think normally because the host is multi-home PE, but and all the multi-home PE should know the binding and advertise such binding to the remote PE. So normally there will be ECMP pass to the multi-home PE. So maybe I can discuss it offline.
Okay, thank you. Krishna, you're the next one. So please stick to your 15 minutes, please.
I'll try my best.
You have no choice.
Okay. As you say.
Okay, I'm Krishna Swami from Cisco. I will be presenting this EVPN first off security on behalf of my co-authors. So this has been already first presented at IETF 116, then followed by some updation in 117, and also at IETF 119. So wanted to give a quick background about this particular draft and also the work done, and wanted to request for our group adoption. So just a quick background. So the DHCP Snoop database, right, so which is built over the DORA message exchange of a DHCP protocol, so which is mainly creates an IPv4 and an IPv6 to address to the MAC binding. Right. First off, security features like ARP inspection, ND inspection, and IPv4 or IPv6 source guard, they make use of this DHCP bindings to determine the whether the traffic or the ARP and ND are received on a proper interface. Okay. So FHS is a kind of a widely deployed feature, right? But there are two issues when we enable an FHS in a EVPN network. So one is multi-homing and other one is the host mobility. I'm going to talk about it in the next slides. Right. So what are we trying to do as a part of this particular draft is, when these DORA messages exchanged on a EVPN multi-home devices, and if it lands on only one of the multi-home device, then the DHCP snooping database gets built in there, right? So the multi-home peer will not have this snooping database. So now, if if any traffic or ARP or an ND comes on that multi-home device where we don't have the snooping database built, then the traffic will be black holed, right? So now created a new route called DHCP sync route. So that is going to peer sync this snooping database between the multi-home peers. So that's the first one. Then also, if the host moves from ESI multi-homing devices to a remote EVPN peer, then the mobility procedures will be broken, because the first GARP message or even the traffic learned on the after move is going to drop the packet because the DHCP snooping database is not enabled, right? So that's the second part. So this DHCP sync route is going to be used to even on the remote EVPN peers to create a DHCP snoop database. Okay, this is the new route format. Right, so there is a create time in seconds, which is being added as a part of the version 1, and it explains in details how this is being used. Yeah, so this draft is stable for last few IETFs, and we request for a working group adoption.
David Lamparter. Two things. Number one, I did read the draft. All the text is referencing DHCP v4. That's not okay in 2024. You need to use DHCP v6 and explain how it works with that. The actual encoding is fine with both, but the text describes operation with v4, and that's not great.
Sure.
The other thing, you don't need this. You should just use the RFC 7653 and 7724, which is DHCP active lease query, which allows the DHCP server to tell your devices what the active leases are and update them actively. So it is the same thing that you're doing, but it's already a DHCP protocol feature. You're building the same thing now in BGP, but it's going to be worse because the DHCP server has no active way to tell you that things changed, because now you're originating it from the snooping devices. So I'm saying in all cases, if you can implement active lease query, it's going to be better than doing this snooping-based approach, and you just don't need this.
So yeah, I think probably what you are referring is mainly for the mobility aspect of it, but in case of multi-home devices, how do you?
No, you just run active lease query on both of the multi-homing ingress points and both get the same information from the DHCP server, and you don't need this.
Okay, sure. Let me sync up with you offline, or maybe you can also send this question on the mailing list.
Any other question on this draft? Okay, so let's move to the second one.
Yeah, thank you. So UMR, right? So the unknown MAC route. So there are some limitations with respect to the mobility, right? So we are going to talk about that as a part of this draft, and I will be presenting it on behalf of my co-authors. Okay, so this is also presented at IETF 116. There are some changes that we have done with 0.1 and version 1 and version 2. So in this presentation, I'm going to go over the what is this UMR and what are the limitations and how we are trying to solve it as a part of this draft, and also request for working group adoption. Okay. So the UMR MAC route in the EVPN world, it is being introduced as a part of RFC 9014, the interconnect solution for EVPN. Okay. So the main use case with the UMR is it improves the MAC address scalability, specifically when we are connecting multiple data centers, right? And it significantly reduces the MAC routes on the leaf nodes. I mean, think like this as similar to a default route in the IP network. Okay. So with the UMR, with the introduction of UMR, right? So there is, it is going to break the MAC mobility procedures, as many of the members here are aware that in order for MAC mobility to work, you need to have the MAC learned remotely and later, learned locally on the EVPN device. Okay. So some of the requirements we have listed out in the draft, and I'm just highlighting it a few here, right? So when we deploy this, the UMR in the DC network, right, we need to keep in mind that all the devices within that particular DC need to be aware of this UMR, and if there are some nodes which are not aware of this, so then it has to be partitioned into two logical entities, such that one set supports the UMR and the other is not. Okay. Then the mobility procedures between the UMR capable devices and also non-capable devices must be seamless, right? So that way we should not enforce that a host attached to the UMR capable device cannot move to a non-UMR device. So that's the intent, right? And of course, the UMR support is an optional, right? So the NIF node, which runs the UMR procedures, it should act on it only when it receives a UMR route. Otherwise, right, it should be optional. Okay. Just a quick, primer on how the MAC mobility procedures work. So without UMR, and then we look at once we introduce an UMR, then how we are trying to solve it, right? Here the X indicates the host or the MAC which is attached to that device. So in this case, in the step 1, it's attached to P1, right? And the AD indicates advertisement, and WD is withdraw, right? And the M1 initially, host is attached to P1, it advertises it, both P12 and the gateway receives it, and the gateway on the DC1 is going to advertise it to the gateway 2, and it's just a normal the EVPN procedures on the DC2, and both P21 and 22 receives it, right? So when the host moves within the DC from P11 to P112, so then RFC 7432, the MAC mobility procedures will kick in, and the sequence numbers get incremented, and the gateway 1 is going to advertise this route to the remote DC, where with a sequence number 1. Okay. Then later, of course, the P11 will send a withdraw, and that withdraw gets propagated. right? So there are no changes. Now in the step 3, the host actually moved to a remote DC, and now it gets attached to PE21. Okay, then since the previous sequence number was 1, now it gets incremented to 2, right? So then that gets propagated to both within the DC and also across the DC. Right? So this is the standard procedure. Right? So now what we are proposing, right, is with UMR, right, the MAC addresses which are part of remote DCs are not propagated to the local DC, right? So that's what the RFC 9014 proposes, where, right, so it is the gateways are advertising the UMR route, so that way they are hiding all the remote DC routes and they are able to scale it, right? So now let's say when the MAC move happens from the remote DC to the local DC, right, then it's going to break the mobility, because the local the PE on a local DC will not have the remote the MAC entry, right, and it starts with the sequence number 0. So in order to address this particular issue, on the gateways, right, we are proposing to have the MAC mobility counters, 2 MAC mobility counters, one for the intra DC and one for the external to the DC. Okay, so these 2 counters get incremented independently, right? So we will see that how does that happen in the next slide. So similar to the previous one, right, the host is attached to P11. So it comes to the gateway and the gateway advertises to the remote gateway. But in the remote gateway, right, so this particular MAC is not advertised to P21 and 22 as defined in the RFC 9014, right? Now in this case, now in the step 2, right, the host moves to P12. The sequence number gets incremented to 1. So now this is an internal, the sequence number. Now the gateway 1 is not going to advertise this. It's going to suppress it, right? It's not going to send it to the remote DC. So as the external sequence number is not really incremented. Okay. So now on P21, when it moves, the host moves to P21. So since it starts with the sequence number 0, because it does not have the local entry, and once gateway 2 receives it, it identifies that, oh, you know what, now this is, I already have this from an external DC and the sequence number is 0. Let me, bump up the sequence number to 1. So once it comes to gateway 1, it says that, okay, I have received this sequence number from an external device as 1, but internally, I already have the sequence number 1. So now when it propagates this MAC information to the local PEs, it is going to bump up the sequence number such that it gets updated on PE11112. If it doesn't do that, then what happens, right? So the sequence number is 1. So then, the PE11 and PE12 will not, it's the same sequence number. So then it will falls back to the 7432.
You have less than 2 minutes.
Yeah, I'm going to just, so this is another section, right? So duplicate MAC addresses. So there are no changes needed, right? So the MAC counter and the timers, what we have defined in 7432 with respect to, N moves with the M timer. So that is going to be still kept on the leaf devices. So there is no change with respect to that on the gateway. So with this, since this particular draft is present from quite a few IETFs, so we are requesting a working group adoption.
We have 1 minute for questions. Any question in the room or remotely? No. Thank you, Krishna.
Stefan, is there a reward for finishing it on time?
No way. You can give me a beer.
It's just the feel-good factor, really.
Hi, I'm Yalo from City. Hi, I'm Yalu from ZT. I'm presenting this draft on behalf of all the co-authors, and it is about SRv6-based BGP service capability. So it has been presented quite a long time ago, so here's a refresh. So as we know, the SRv6-based BGP services reuses the existing AP service and NLR encoding for piercing VPN. And the whole or the part of the SRv6 service is encoded in the SRv6 service TLV. So in the MPLS and SRv6 coexistence scenario, the potential risk is so if the legacy devices only capable of MPLS VPN receive the SRv6 based service routes, it may discard the unrecognized SRv6 service TLV and process it as an MPLS VPN route. So to avoid the problem, the specification in RFC 9252 is implementations must provide a mechanism to control advertisement of SRv6 based BGP service routes on a per neighbor and per service basis. So here's some current methods for SRv6 based service route advertisement. It is mainly done by network planning or configuration. So whether you use a single SR or separate service Rs, at least you need the configuration on some P nodes. So the potential disadvantages. The first is the per neighbor configuration needs to vary with the device capability, especially when you are upgrading your network or you're doing the rollback, the version rollback. And the additional steps of configuration increases the possibility of force and the difficulty of sharp troubleshooting. And there's not a standard way for the network operator to get the PE's capability of SRv6 based route. So when you have devices from multiple vendors in a network, there may be some difficulty for you to manage. And in this document, a new capability code for SRv6 based BGP service is defined, and the procedure is just like other BGP capabilities. So the BGP speaker must not send any update message that includes SRv6 service TVs unless it has sent the SRv6 based BGP service capability in its BGP open message, or it has received this capability from its peer. So in this way, the SRv6 based service route can be controlled automatically, and it is easy to implement. And we've proposed a new version of this draft, and the whole structure is restructured for ease of reading, and we add another current practice and the analysis in the draft, and welcome feedbacks and comments.
Jorge, go ahead.
Jorge Raban, Nokia. Well, thanks for the presentation. I think this would have been great to have at the time we did RFC 9252. But now in brownfield deployments, this is really difficult to deploy, because when you upgrade one of the PEs, right, and basically your text is saying that you must not send an SRv6 route unless you receive the right capability. So basically in brownfield scenarios, I don't think this works well. So I wonder if, given all the amount of implementations and deployments that we already have for SRv6, I wonder if this has real value. And for greenfield scenarios, yeah, this is still valid, but I'm not sure. I'm wondering if it is worth pursuing or not. That's my comment.
Ketan?
Ketan Talaulikar, Cisco. Just a feedback. The capabilities, ability to use capability is well known to understand, what message I can send or not. But I think on slide number 2, you are saying that right now, if you go one more, yeah, this one, that, sorry, this slide. So this is how it is done today. I agree. To have a brownfield network where we have MPLS and SRv6 and both of them talking to each other does require a lot of planning and configuration. My point is, by introducing a capability, we are not going to be able to do away with any of this. If you go to the next slide, I think this says that everything is controlled automatically and work, but this is not how it is really. The capability is only just to know whether I can send a route or not. But everything else, what was there in the previous slide, we still need to do. And that is what we have the knobs for.
Yes, this capability won't solve everything. Then you still need some configurations.
You need all the configurations.
Ali, you wanted to add something? No, you're good. Okay. Yeah. As a working group chair, I tend to agree with Jorge. It's probably a bit late, but we will see what the working group says. But this would have been a good idea at the beginning, but now we have our deployments and so on. So we'll see.
Yeah, it may help for the graphic implementation. Yeah, thank you for all the comments. Thank you.
Okay, last speaker.
And this can't be. 10 minutes is too much.
10 minutes. Yeah. I will talk about it.
Should be good. I have to go soon.
Okay. Hello, everyone. I'm very glad to give this presentation about EVPN extensions for Event 6. I'm Xie Zhongfeng from China Telecom. Yeah, this document introduces extension of EVPN for Event 6. Event 6 is a new idea, so it is a mechanism to carry Ethernet virtual network, provide Ethernet connectivity between hosts dispersed on different sites. So it leverages the IPv6 advantage by encapsulation the Ethernet frame into the IPv6 packet. So this document introduces two types of routes and its procedures. Yeah, this shows the architecture. Event 6 implements the function by introducing adapt functions, and it will encapsulate the Ethernet frame into IPv6 packet directly without extra head. So it has high efficiency. It's different from VX9. And so to support operation of Event 6, the following new route types, type 12 route and type 13 is a tentative number to be defined. So type 12 is Event 6 auto discovery route, and type 13 is a MAC IPv6 advanced route. Actually, it is related to the mechanism of Event 6. It is defined in area working group. And by mapping the MAC address and using the virtual network identifier and the set prefix into the IPv6 directly, address directly. So we need to announce the mapping relationship from one site to another site, so the packet can be encapsulated for transmission. So the EVPN type 12 route is used to advertise which is virtual Ethernet identifier is a 32 bits identifier, and IPv6 mapping prefix allocated by the P for virtual network between Ps to establish a head-end replication list, which is used for automatic discovery of P, the dynamic establishment of Event 6 tunnels. This is a lightweight tunnel. The second route is 13 route. It's used to advertise the MAC address and IPv6 addresses of the host between PE devices, also including the information of virtual Ethernet ending fair is a 40 bit, 4 bytes, 32 bits. So it's larger than that of VXLAN IDs, which is 24 bits. So this is the procedures. Firstly, even 6 will need the setup tunnel for BOM traffic. BOM traffic refers to that kind of traffic that will be forwarded to multiple destinations that cannot be addressed to the or that come to the intended destination only. So this is the first step. The second step is that we need to generate the host entry in the MAC VF tables of P devices. The general EVNC tunnel is designed for unicast Ethernet traffic forwarding. So the prerequisite for establishing universal tunnel is to generate this kind of host MAC address mappings in a MAC VF table, which is achieved by dynamically exchanging tab 30 routes. So these 2 routes are specific to EVN6 functions. So as the third step is Ethernet transmission because the data has been available in P devices. So the host can send Ethernet frame to each other, and the hosts at different sites can transmit unicast Ethernet frame to each other through the EVN6 tunnel. It's the MAC address to IPv6 out of IPv6 mapping is 1-to-1. This is one of the basic feature of the EVN6. So next step, we have implement system, and we are doing the field trial, and we are looking for receive comments, suggestions, make further refinements to this document. We also ask for more reviews, and maybe it can be considered working groups. Okay.
Yeah, Krishna is the first one. Or do whatever you want.
So by going over your draft, I saw a solution, but I didn't see what problem this solution is trying to solve. So can you explain what is the problem currently and what problem you're trying to solve?
Yeah, actually, we focus on the scenario of Ethernet virtual network transmission over IPv6 network. So we want to use IPv6 to improve the transmission efficiency because there's no extra overhead.
We already cover, EVPN currently covers, L2 and L3 over SRv6 and over MPLS. So is the problem you're trying to solve, is it like you're trying to do a more efficient encapsulation? Is that what you're trying to do?
Yeah, that's only one.
Because I'm not sure exactly what the problem is.
Yeah, because MPLS has limited coverage in the actual world, right? But IPv6 has been deployed all over the world.
EVPN goes over IPv6, EVPN goes over SRv6. Already there are RFCs for it.
Okay, yeah.
Yeah, let's take to the list. We are out of time. So Krishna has still a comment. Okay. So no, but.
So anyway, mine is like pretty straightforward one. So the route types 12 and 13 already been referred in other drafts. So you cannot just refer it again here in your draft.
We have a bigger problem than the route types.
Okay. Yeah. I just want to try to explain to Alice's question. Currently, EVN6 just provided another encapsulation, forwarding encapsulation. It is more efficient than the VXLAN or SIV6 because VXLAN is run on the UDP protocol, and the SRv6 there are more overhead. So but EVN6 just directly in the IPv6.
Just let me, basically you're saying encapsulate the MAC into the IPv6 header because we have enough base, we can do this kind of thing. Just FYI, like 12, 13 years ago, we were trying to decide on the encapsulation. We discussed VXLAN, Geneve, NVGRE, and so forth. At that time, 12 years ago, we discussed one of the options was incorporating MAC into the IPv6, and we decided not to do it.
Thank you.
Okay, thank you.
And if there is further discussion, please take it to the list. No, but please take it to the list. Please take it to the list. Just before we leave, one comment to Kireti. We saw your comment regarding VPLS multi-homing, so we will really appreciate if you want to close the draft because it's widely implemented. So yeah, please do. Thank you.
Matthew quickly talked to me yesterday about it, so I said I will do it. Yeah.
Many thanks for your help. So this is the end of the BESS session in Dublin. So thank you for your attendance and talk to you or see you in Bangkok.
So I asked it quickly before we first discuss this.
Yeah, I saw him in person. So he couldn't escape.
That's the good thing coming around here.
Yeah. Yeah. But
Thank you.